All right, remember yesterday we were doing some word problems? We're gonna do some more today. All right, so we're ready. I'm on the back of page 13. And very last problem, 2C. A car was worth 2, 3, 4, 5, 6 when you left the lot, and it's now worth 18,765. Find the percent of decrease. Well, this is good review from yesterday, right? Percent of decrease. What's my little formula? Difference over original. So the difference in the two numbers is 2, 3, 4, 5, 6 minus 18765. Oh, did I type it in wrong? Oh, you've already got the answer. So the difference was 4691 over the original price of the car. I got about 20%.
We did this yesterday, right?
Not C. We're on the very last problem. Problem C.
Yeah.
Well, it's 0.19999, which when I round that off, I mean, there's so many nines after it that it's about 20%, isn't it?
Yeah.
So I would say it's about 20%. A 20% decrease in value. You must know this formula right here, guys, difference over original. That will be a test question, so make sure you remember difference over original. Okay? All right. Now we're going to do another box problem. Remember when we did these the other day? A while back, we built a box by tearing out the corners of the paper. So let's look at this for a second. We have a piece of paper. And we're going to cut out corners from each side. And we don't know how big those corners are, but they're squares. We'll call them X by X. And the paper was 14 by 12 or 12 by 14 to start with. And we're going to fold up the sides to make an open-topped box. So, what's happening, in case you need a visual, if we had more time, I'd have you all make one of these. I'm just going to tear the corners out, fold up the sides, and then these flaps here. So does that make sense to everybody? Get a little box, right? Right? Okay, so I want you to look at this box. All right, and then I want you to look at this box. I'm starting with the same size piece of paper, exactly the same size paper. I'm ripping out squares. They're not exact because I'm not measuring, but you know, they're supposed to be squares. And I'm going to fold these up. Now wait a minute. That box looks different than this box. And if I had a big giant bag of M&Ms and dumped them in this bag, in this box, and then filled up this box too, do you think these two boxes would hold exactly the same number of M&Ms? No. They're different size boxes. But they were made out of the same size paper. So what made the difference? The amount that I ripped out. So the volume of the box I'm creating depends totally on the size of the corners I cut out. And your job as a mathematician is to figure out what size these X's have to be so that your box holds the absolute most M&Ms that it can hold. In other words, the volume is a maximum. Okay? So to do that, it's pretty simple. we're gonna write an equation for the volume of a box. How do you find the volume of a rectangular solid, the volume of a box? Length times width times height. So length times width times height. Alright? So for this box, the original length was 14. But what did I do? I ripped a couple of things off of it, right? So what is it now? It's not 14, it was 14 minus 2x, because I took an x away. And what about the width? I did exactly the same thing. So the width is going to be 12 minus 2x. And then keep in mind that the height of the box is the size of these flaps I folded up. So how big are the flaps I folded up? X. That's X. Right there's X. Now, guys, in a minute we're going to do another problem just like this. But the paper isn't going to be 12 by 14. It's going to be something else. That doesn't matter in the setup. The setup will always be dimension minus 2x, other dimension minus 2x times x. That will never ever change. Now when you graph that equation on your calculator, and that's where we're going in a couple minutes, we're going to graph that on our calculator, but when we do that, it's not going to tell us specifically what we need. To make it tell us what we need, we have to set up the domain. And the domain is x min and x max on our calculator. Domain, you know, is x's. So I want you to think about what I did here on this piece of paper. These things were x's that I ripped out. Tell me about how little or how big those x's could be. Could I rip off negative 2 inches? No. What's the absolute smallest? Well, actually I could do a half. I could go all the way down to 0, right? Can't be 0 because if it were, I wouldn't be ripping anything, but it can go all the way down. It could be 0.25, 0.1, whatever. So my minimum is going to be 0. No negatives allowed. Now what about the maximum? Remember, the paper was 12 by 14 to start with. So could I rip off 20 on this side and 20 on this side? No, I've only got 12 by 14 to work with. So what is the absolute biggest I could rip off? Now think about that. It's coming off each side. So could I do 11 off each side? No, because I only have 12 to start with. 5? What about 5.5? Could I take off 5.5? Could I take off 5.8? I can take off everything up to 6. Why can't I take off more than 6? Because I only have 12, and I'm taking it off both sides? Right? So where did that 6 come from? I looked at the smallest side of paper that I had, and I cut it in half. Because that is the absolute most you can rip off. Now, you can't rip off 6, because then you would have nothing left. But you can rip off everything up to 6. So your domain is the interval from 0 to 6. So you will be asked to write the domain, and you're going to write it as an interval. Open interval. Don't use brackets, because it can't be 0 and it can't be 6. Huh? Yep, they're like asymptotes. That's right. Now, they are not going to be asymptotes, because this equation doesn't have any, but yes, they behave like asymptotes. All right, so now I think we're ready. We're going to go to our calculator, and we're going to go to window, right? right here, where my finger's pointing, window. And you just told me that X min is 0 and X max is 6. Now, Y min will always be 0 in this problem because Y is the volume and the volume can't be negative. So put 0 in for Y min. Y max is actually what we're looking for. So at this point, we have no idea. So let's guess a number. I'll just say 200. That is a total random guess. It's either gonna work or it's not. If it doesn't, we'll fix it, no problem. All right? So X min, X max, Y min is gonna be 0, and I guess Y max is 200. Okay? Now, go to Y equals and type in exactly what I wrote here. Don't multiply it out. Type parentheses, 14 minus 2x, parentheses, 12 minus 2x, and x. And hit graph. What you should see, it's not a parabola, but it kind of has a parabola look to it. Something like that. Now, 200 turned out to be a good guess because my job is to find the top of the mountain, the maximum, and I can see it. Okay, now in a minute we'll do one where we can't see it and I'll show you how to fix it. It's real easy. But this one works. This is exactly what I want to see. So now, second calc maximum. Left bound, we did all this before. Left bound, right bound, in the middle, and I got 2.15, comma, 160.58. So down at the bottom of the screen, after you hit, it says left bound, right bound, guess. Down at the bottom, if you hit enter, or at least on mine it's at the bottom, you see an X and a Y value. Okay? Now, the question says, find the maximum volume of the box. There are two numbers here that potentially could be the answer to the question. Keep in mind, this is X and this is Y. When you set your problem up, what did X stand for? The size of the corners? So what this is telling me is, okay, if I'm gonna make another box, I'm gonna cut out corners that are 2.15 inches. And if I do that, the volume of my box will be 160.58 cubic inches. So the answer to the problem is the Y value, because the Y value is the volume, 160.58 cubic inches. All right, we're gonna repeat. We'll do exactly the same thing. The paper, though, is 20 by 24. So what will my equation be if the paper is 20 by 24?
20 minus 2x, 24 minus 2x, and x.
And these are all multiplied, right? Length times width times height. You see how that's exactly the same as the last one? Except I'm using my new dimensions now because my new paper is 20 by 24. Now, tell me about my domain. What is the lower limit on my domain? 0, it's always gonna be 0. X can't be negative. What's the upper limit this time?
10.
I heard a 10 and I heard a 12. Remember, you gotta go with the smallest dimension. So the smallest dimension is 20, and half of 20 is 10. So that is your maximum X value. Okay? All right, let's put it into our calculators. I wanna show you something. So, change your window, 0 to 10, and leave everything else the same. All right? Leave everything the same. Go to equation, type in your new equation, 20 minus 2x, 24 minus 2x, and x. And hit graph. Now, do you see what happened? What happened this time was you saw this go up, and then it disappeared, and then you saw it come back down over here. So what that means is, my calculator's not set high enough. So I'm gonna go back to my window and maybe change that 200 to 400, 600, change it to something. If I change it to 400, that's not big enough. 600 is not big enough, let's go with 800. Barely, but it's there, right? So do you see how I have to guess my Y max, but if I guess wrong, it's no big deal, you just guess again, right? And the objective is to see the top. So as soon as you can see the top, you're good. And then you're going to second calc max, left bound, right bound, yes. I got 3.62 and 774.16. So this question is exactly the same. Find the maximum volume of the box. So what are we gonna say? The maximum volume of the box is 774.16 cubic inches. Now, the other question I could and might ask is, what size corners should you cut out? And if that were the question, 3.62 inches, right? That's how big the corners are. That's your X. Whose calculator's in here? Okay, doesn't do us any good when it's at home, does it? Type anything in on this puppy? What? You'll have to cover it after class. We've already been through all this earlier, okay? All right, so now we're moving on. Now our letter F. So we've done our box problems. Now we're going to a problem like we looked at yesterday. Find the final cost of a sweater that originally was $52.50. It's on sale for 25% off, and there is a 7% tax. So we're going to try to figure out how much it's going to cost us at the cash register. So think about what we talked about yesterday. If we are taking away 25%, then this first number we're multiplying by is what? 0.75. 1 minus 0.25. And then the second number we're multiplying by is 1.07, which is 1 plus 0.07. Remember, if it's coming off a discount, you subtract it from 1. If it's an add-on, tax, tip, whatever, you add it to 1. So the answer to the question, real simple, is 5250 times, I gotta catch up, times $42.13. Is that what you said?
Yep.
Yep, that's right. That's how much it's gonna cost. G. Find the final cost of your restaurant meal if the food costs $23.12. There's a 7% tax. And there's a 15% tip. Now this one's different because these are both gonna be add-ons, aren't they? Which is fine. What am I gonna multiply by here if there's a 7% add-on? 1.07? 1 plus 0.07? And what about a tip? 1.15, 1 plus 0.15? That's okay. Doesn't matter. Oops, I gotta type in the right number. $28.45, is that right? Everybody got it? One more kind of problem. Yep, we're gonna do one more kind of problem. And it is also a review problem from Algebra 1. It's called a mixture problem. Read H and see if you can figure out what's going on there. Just understand what we're doing here. So I got a couple of different kinds of lemonade, some weak lemonade and some strong lemonade. And then I'm gonna mix them together and get some medium lemonade, right? When we do mixture problems, you didn't necessarily do it this way in Algebra 1, but I think it's the easiest way. You take the amount times the percent of the first kind of lemonade. So here's my weak lemonade. How much of it I have and what percentage it is. Add it to the amount times the percent of the strong lemonade, and that will equal the amount times the percent of the final mixture. So basically, amount times percent plus amount times percent will equal amount times percent. There are 6 pieces to this equation. 3 amounts and 3 percentages. Let's fill in everything we know from the problem. So what do we know from the problem? We know the first percentage we're mixing is 12%. And remember, you never put 12%. It's gotta be the decimal, 0.12, always. And then we have 18 gallons of 20%. And we're gonna get lemonade that is 18%. So of the 6 pieces of information I need, 4 of them are right there in the problem. The question says, how much of this, So I'm gonna call that X. How much it? And now I just need to figure out what I'm gonna put here. And I want you to think about that for a second. Here's my bucket. I pour in X gallons, and I pour in 18 gallons. How much do I have? If I poured in X and I poured in 18, what do I have? 18 plus X. Think about it. Don't these two amounts added together have to be the total amount? So I'm ready to solve. It's ready to go. So this is going to be 0.12x. What's 18 times 0.2? 3.6. 18 times 0.18. I'm going to double check that. This is a distribute. Yeah. Okay, this is a regular equation. Now you can solve this. Maybe I'll subtract this over to the other side. And this does cause us some problems if we're not careful. What is 0.18 minus 0.12? 0.06. So make sure, I mean, you're gonna have a calculator, so type it in if you need to. But make sure you don't put 0.6. It's 0.06. And then I'll subtract 3.24. Correct me if I'm wrong, I'm just trying to do this without a calculator. I got 6 gallons is my answer. So the question was, how many gallons, or how much, was it the unit gallons? Yeah. How much? 6 gallons. Okay. All right, one more that we're doing. We're not going to do J and K, so you can cross those off if you want J and K. You can cross those off your notes. Don't get rid of these notes though, because chapter 2 starts down there. We're going to need it still. But cross off J and K. All right, how much 22% should be mixed with 74% to get 100 gallons of 50%? All right, so I'm going to start with my setup. Amount times percent plus amount times percent equals amount times percent. That setup will never lead you astray. You will always be able to do the problem with that setup. Okay, what did we do next then? After we got this all written down, what did we do next?
We found the numbers that went
Okay, so we know we're gonna have this plus this equals this, right? And in the problem, you should always be able to get 4 of those. There should be 4 of them in there. So what do we know this time? We know we've got a 22%, I'm putting that in the percent spot, mixed with 74% to get 100 gallons of 50%. So just like before, there's 2 blanks. Right?
yes.
Now, the question again says, how much? 22%? So it makes sense to me to call that X. That's what I'm trying to figure out. How much? Now, don't make this one 100 plus X, because these two added together have to give you the 100. Right? Any thought on what that might be? Now, if you make it X, then what you're assuming is you have the same amount of both of these, and you can't do that. Okay? So don't call it another X. It has to be something else. Jacob?
Would you be using like X over 2?
No, but we are gonna use X. We're gonna do something to X. I want you to think about this for a second. Okay, so let's say this is my first container, my second container, and then my third container, and I know I end up with 100, okay? So what if this one is 25? What would that one have to be?
100 minus X?
Oh yeah, don't you subtract to figure out how much this is? So this would clearly be 75, which was 100 minus 25. So this is gonna be 100 minus X. Remember, add these two together to get the last one. If you have the last one, then you're gonna have to subtract to get a smaller amount. So if your blank is here, like it was in the last problem, then it's add, 100 plus X or whatever. If your blank is here, it's gotta subtract 100 minus X, or whatever that number is. Guys, are you paying attention? Okay, all right, let's solve it. Just like a regular equation. So you're always gonna have a distributive somewhere, so this time the distributive is right here. Tell you what I came up with. I got 46.15 gallons. Yep. Remember here's my dividing line, this is field stars. So these two get added together, so negative 0.52x plus 74, subtracted the 74 and divided. Anybody else get 46.15? Good. That's the answer to the question. All right? Everybody good with that? Get your homework out. 1.7, let's take a look at it. We'll do one together, or two. Homework. Which will be due on, what's today? Monday, due on Monday. This is period A. All right, so look down through, there's 4 kinds of problems on the paper. So I'm gonna do one with you right now, and then you can help each other and work on some others if you want. But let's do one together as a group. So, number 1 is one of those, how much does it end up costing after we have taxes and all that stuff? Number 2 is a percent increase, decrease. Number 3 is a mixture problem like we just did. And number 4 is a box problem. Okay, so of those four, Sandra, which one do you wanna do?
How about we do number 3?
Number 3, that's the kind we just finished. So, it's a mixture problem. So, please write down on your paper, there's plenty of room there. Write down amount times percent plus amount times percent equals amount times percent. And then I have my parentheses, so amount times percent, amount times percent, amount times percent. All right, so let's fill them in. What do we know from the problem? Well, our first percentage is 0.19. Oh, wait a minute, this is tricky. How much 19% orange juice should be mixed with pure orange juice? What's the percentage of pure orange juice? 100. So in terms of a decimal, that's gonna be a 1 right there. Don't put 100, it's 1.00 if you wanna have a decimal. Is everybody okay with that? Pure orange juice is 100%. And we want 63% percentage to end up with. And the other thing we know is we have 80 gallons of this. Make sure you got the 80 with the 63, because that's where it goes, right? How much? 19%. And now you need to fill in the parentheses, the missing parentheses. So Abby says it's 80 minus X. So either that's exactly right. It's either 80 plus X or it's 80 minus X. Is she right, or do we need to change it? She's right. She's right. The only time it's plus is if you're over here, guys, because this is the total. Total means add. Add them together to get the total. So she's exactly right. So here we go. Go ahead and solve it. See what you come up with. Remember, if they're on the same side of the equals, you have to add them together. Anybody match me yet? You still working toward it? Alright, you got 5 minutes. You wanna just continue working on that homework you can. If you wanna work on your 1.6 homework, you can. But this homework will be due on Monday.